All right, continuing with another example here. Finding your derivative. So I'll start off with my notation. I'll just to do different, let's just do y prime this time. Okay, so I have to substitute into this x. Okay, so I have to start off by substituting the x plus delta x first. So I have 4 divided by x plus delta x. So that has to substitute for this x, and then I've got my plus 1. And then I have to subtract from that the function. And then this is divided by delta x. Okay, so this time, if you do direct substitution, or I forgot, hang on a minute, I forgot I actually need to write this. I got ahead of myself. So I should have y prime is equal to this, and then have this. Okay, so if you do your direct substitution now, then you would end up, again, with that indeterminate form of 0 over 0. So we've got to do some simplifying. This being a complex fraction, you need to go through and multiply everything by the common denominator, which your common denominator is going to have to consist of this denominator and this denominator. So we're going to have x plus 1 times the x plus delta x plus 1. Okay, so with the first term, of course, all of this will cancel this, so I'm left with 4 times the x plus 1. So I'm going to go ahead and distribute my 4. So that's going to give me 4x plus 4. Right here, the x plus 1s are going to cancel, and I'm going to go ahead and distribute this step as well, but don't forget the minus sign, so I'm going to treat this as a negative 4. So I would have a negative 4x minus 4 delta x minus 4. All right, do not multiply out your denominator, just this times this times this. Okay, so doing some simplifying with my numerator, my 4x's are going to add out, and my 4's are going to add out. So I'm left with a negative 4 delta x on the top. Okay, now your delta x's are going to cancel. So that will leave me with negative 4 over x plus 1 times x plus delta x plus 1. Okay, so you've done all the simplifying that you can do. You're actually ready now to do the direct substitution. So you are substituting 0 in for the delta x. So when you simplify this, so I'll say y prime equals. All right, this is going to give you an x plus 1, so you have an x plus 1 times an x plus 1, so we can just write that as x plus 1 squared, or if you want to leave it separate, you can. This would be your derivative. Okay, next. Okay, so we'll have g prime of x Okay, Now remember, your first step is to substitute x plus delta x into the function for x. But since this function doesn't contain an x, there is nowhere to substitute the x plus delta x, therefore that's just 7. Okay, then you're supposed to subtract the function, which your function is just 7, all over delta x. So this one is a lot easier than the other ones, but it gets confusing for you because there is no x there to substitute into. So now what we have is the limit as delta x approaches 0 of 0 divided by delta x. Okay. Now, you may get confused in the point that you think, okay, well, let's do direct substitution, but just the fact that you have ended up with 0 on the top. Now remember, delta x is approaching 0, so if you think about those values as you're getting closer and closer to 0, this could represent like a negative 0.5 and then a negative 0.4 or negative 0.3, like if you're approaching from the left, or you'd have the same situation from the right. But when you have 0 divided by some number, then that is just equal to 0.